So good morning, friends. Uh, good morning, and hearty welcome to you all again for the second lecture of introduction of 8085 microprocessor. And just for to recall, will be again. So again, we will recall what we have learned uh, the yesterday, the last class. The topics that we were expecting to cover was the introduction of 8085, features, pin configurations, architecture of 8085. Today we are going to take this architecture of 8085 and the 8085 bus structure, then instruction stack, addressing modes, and timing diagram. So we'll be covering all those sections in the coming class. So we have learned about microprocessor. In the introduction itself shows that the microprocessor is a central processing unit edged on a single chip. A single integrated IC has all functional components of CPU, namely what type of functions it can process as arithmetical logical unit, control unit, and registers. So these are all inbuilt inside that CPU 8085. It is actually a 8-bit microprocessor, and the address lines are 16-bit. So as we have earlier discussed, that it has 8 data lines and 16 address lines. Hence its capacity is 2 raised to power 16. This is 2 raised to power 16, and that is equivalent to 64 kilobytes. Equivalent, it is not equal to, but it is equivalent. So the clock frequency is 3 megahertz, and it requires plus 5-volt power supply. um, what it is. Yes, plus 5-volt power supply. It is NMOS technology, and having around 6,200 transistors inbuilt inside it, and it provides around 74 instructions with 5 addressing modes. So this is what the features were. Then this is about the pin configuration that we have studied. Now this pin configuration is divided into 6 major groups. The first one is the data bus, the second one is the address bus, third one is control and status lines, and fourth one is externally generated signals and serial interface, and the last one is power supply and clock. So we will be discussing this again. We will be repeating. So the first one is the address bus. I have told you that address bus is of 16 bit wide, that is 16 lines are there, and it starts from A15 to A8, that is upper um, higher order address bus, and the below one, lower one, is 87 to 80. So the total is 16-bit address lines, and this 8780 is multiplex, and this same 8-bit data line can be used, data bus can be used for data transfer also. So this is what we are going to study in this class today also. So address bus and data bus. Then we have control lines, that is read, write, input, output, memory bar. Then we have status lines S1 and S2. We'll discuss it in the signals. Then we have address latch enable. This is what we are going to discuss in this class today. So address latch enable is also there. Then we are having the external latch IC for demultiplication. This is what I will be discussing. Now this is the simplest block level pin configuration of 8085. Here we have studied that we are having 8-bit higher order address bus, that is A8 to A15. Then we have 87 to 80, which are multiplex and which can be used not only for the address but also for the data, the same 8 lines. Now how they are going to be used, we are going to discuss in the coming class. Then we are having address latch enable. Then we are having S1 and S0. This address latch enable is going to control this 87 and 80. So we will be talking on that. So S1 and S0. Then we have input, output, or memory bar. Whether the instruction is concerned with the input output devices or whether it is concerned with the memory, that is being recorded, that is being say monitored by this pin. This is called as input output oblique memory bar. Then we are having read bar, then write bar. Then we are having clock output, reset output, then interrupt acknowledge, hold HLDA acknowledge, hold acknowledge, that is for direct memory access. then we have hold, ready, and we are having 6 interrupts 5.5, interrupt 6.5, 7.5, and trap. So in all there are 5 interrupts. Then we have serial input data line, then we have serial output data line also. These two, x1 and x2, are for the crystals. Then we are having plus 5 volt supply and ground. So these are all about the pin configuration. Now the exact pin configuration we have discussed in the last class, and this is something like this. So the pin configuration of 8085 consists of 40 pins. So we are having 40 pins dual inline package, which says that dual inline means we are having 2 lines of say pins. So one is on the left hand side and the other one is on the right hand side. The first line is say 20 pins are on the first side and 20 pins on the second side. So we are having 2 lines of pins, 20 on either side. So the first uh, 20 pins we will discuss. We had discussed earlier also. So AD0 to AD7, it starts from pin number 11 to pin number 19, and pin number 20 is ground. Pin number 40 is plus VCC. So the last pin of all the digital ICs is supposed to be in the first line is supposed to be the ground, and the last pin, the maximum last pin in the digital IC is for the positive supply. So 40th pin is plus VCC, 20th pin is ground. Then from 12 to 19, we are having 8 pins, which gives you AD0 to AD7. And from 21 to 28, we are having A8 to A15 address lines, A8 to A15. See, simple. Then coming on the left hand side, again, we are having interrupt acknowledged first. Then we are having 5 interrupts depending on the priority. Interrupt RST 5.5, that is reset 5.5, reset 6.5, reset 7.5. Then we have trap. Then we have serial input data, and then we have serial output data. These are the serial lines. The data can be taken serially inside, and the data can be given serially out in the output side also. Then the third pin is reset out, and first 2 pins x1 and x2 are for the crystal to be attached. That is, we are going to connect a 6.14 megahertz crystal. The frequency which is required to this 8085 microprocessor is 3.3 megahertz. Then coming on the right hand side, 21 to 28, we are having A8 to A15. 29th is S0, that is status. And then we have address latch enable. 31st is write. 32nd is read of bar. If you are able to see, there is a complement on both the lines, which implies that if the 8085 microprocessor wants to read the data, this terminal should be low. Active low pins are there. So read and write. Then we have S1. So S1 and S0 are the status signals, which determines the determines in which mode we are going to use this 8085. So S1 and S0 can be combined to have a 0, 0, 0, 1, 1, 0, and 1, 1 sort of status, and accordingly we will have different types of modes. 34th pin is of input and oblique memory bar, which shows that whether the signal is of input output or whether it is recommended for the memory. Then 35th is ready, and 36th is reset in. Then 37th is the clock output. The clock output is given to all other devices which needs to work in unison with this microprocessor. So the clock out is given to all those devices, peripheral devices. Then we have 38, that is address latch, hold acknowledgement, and then we have hold. These two signals are for direct memory access. So memory can be accessed directly by using this hold and hold acknowledge signal. And the last pin is plus VC. This is what we have done in the last class also. So we'll be continuing for the next class. Now what we were talking about the multiplexing of address and data bus. So we are having 16 lines for that. So the A15 to 8 are the simplest 8 wires, which are only specifically used for the address of the memory location. So, and the other 8 bits that are used here. If you are able to see 87, 86, 85, 84, 83, 82, 81, and 80. So these are being multiplexed. So that same 8 wires are going for A0 to A7, if you are able to see on the right hand side. And these same are multiplexed for the data also. And this is that particular IC which we are calling as address latch enable. So this address latch enable signal gives this IC to show whether the data is for the memory or whether the data is for the address. And this address latch enable is going to control these 8 lines for data as well as for the address. So this is about the address latch enable. I hope you have got this, how these are being multiplexed. uh, the same 8-bit can be used for the address as well as the same 8-bit can be used for the data lines. So this is how it's going to work. So this is demultiplexing of address and data bus. I hope everybody has understood this. If you have any problem, you can ask me on this. So shall we continue, and we'll be having questions on the last session. If you have any questions, keep writing on it. And if you are able to see it on your mobile phones, I request you all to kindly take snapshots of all those things so that you will be able to recall it whenever you require this. So this is of demultiplexing of address and data bus. Then the next one, which is very, very important, is the architecture of 8085. Now, what is inside the 8085 IC? That is what we have to study, and it's really very say it's really very complicated to understand what is inside a 8085 IC, because there are having n numbers of n number of counters, or adders, subtractors, and every sort of I say many circuits which are there. So what we are doing is we are going to study this 8085 in terms of a block level diagram. That is we called it as 8085 architecture, in which I hope you are able to see this. So in that we are going to learn about the block level diagram of 8085. So if you are able to say this, I hope you are audible and clearly visible also. So if you are able to see this, we are having internal block diagram of 8085 IC. So in this say in this that the first important are the registers. If you are able to see this, so where I'm showing my cursor, so these are the general purpose registers that we are going to use. So the main general purpose registers are uh, accumulator. This is the accumulator. And then we are having BC, DE, and HL. So these are 6 general purpose registers: BC, DE, and HL. So these all are 8-bit registers. And the next one is the SP, that is the stack pointer, where the address of the stack is being stored. I will let you know as we will proceed further. And then this is the program counter. So they are going to keep a 16-bit address lines. So stack pointer is going to take a 16-bit address line, and program counter, where the program is there in the memory location, that is being recorded, that is being monitored by this program counter. Then we are having increment decrement address latch. So the program counter, after every execution, the program counter increments itself to the next memory location where the data is being kept. So that is being recorded by this address increment decrement address latch. Then again, if you are able to see, we are having address buffer and data address buffer. So we are having 2 8-bit lines. This same line is going to be used as address when it is communicating with this address latch. So total we are having 60, and the same line can be used for the data lines, which we are able to see here, which is going in the upward direction. So this green pipe is of 8-bit width. So it is having 8-bit wires or 8 wires in it, and therefore it is called as a 8-bit bus. So if you are able to see this, um, so what we have started is the general purpose registers B, C, D, E, H, and L. So we are having 6 general purpose registers. Registers you have studied in semester 3, in which we have studied, say, shift registers, right shift, left shift, in which we are having 8 flip flops. So 1, 2, 3, 4, 5, 6, 7, 8. So 8-bit data can be stored at a time in this register. So they are called as general purpose registers. So B and C, D and E, these are the general purpose registers. H and L are also general purpose registers. To mention here specifically, I hope you won't understand right now, but as you are going to use this, you'll be understanding that why I'm telling this. HL specially, this is a pair. So we can have a pair also of 16 bits. So BC can be one of the default pair, D can be one of the default pair, and HL can also be one of the default pair, register pair. So if we have a pair, then it becomes a 16-bit byte register pair. So we have a default pair like BC, D, and HL. Now, by default, HL is always used. Just listen very carefully. Register pair HL is always used for memory location. So whenever the data is stored in the memory location, the address of that particular memory location is being stored in HL. I hope you got that. So that is why it is a 16-bit address. So this HL and whatever address it has, the data will be there in that memory, particular memory location address, the data will be over there. So whenever we are uh, executing or using the instructions which is having a memory as one of the storage location, which implies that indirectly that the address of that data should be in HL pair. I hope you got this. So HL pair stores the data, stores the address of the data. I hope you got this. So it specifically stores the address of the memory location where the data is being stored. And therefore, whenever we use the instruction which is concerned with memory, just like add M, this is one of the instruction, that is add memory location. So the data is stored in memory location and that is to be added. And by default, one of the data means for addition we require 2 data. So one data is always in this accumulator. So accumulator is again a general purpose register, but it has a separate specification. Means all the arithmetic and logical units is done by this, through this accumulator. So one of the data, while adding or subtracting, while doing any of the arithmetic and logical operations, one of the data is expected to be in the accumulator. I hope this is clear. So we are having 6 general purpose registers, B, C, D, E, and HL. Then we are having SP, that is a stack pointer. Then we are having program counter, which keeps the track of the programs. Sorry, for a second. Excuse me. So we are having 6 general purpose registers. They are 8-bit registers: B, C, D, E, H, and L. B and C are default pair. This can be used as pairs. So we are having BC, DE, and HL. As I told you that HL is specifically used for to store the address of the memory. When when you will be performing some programs, you'll find that it will have the first instruction as um, uh, say load HL pair. So which implies that the HL pair is to be loaded with the memory location first. So this is for the memory location address where the data is being stored. Now you can use that for uh, the addition or for other processes. So HL pair is specifically meant for that. Other than that, if you want to use this HL pair or H or L register separately for say addition or deletion of this sub processing of some data, you can use this H and L registers too, which can again being able to process 8 bit of data. So this processor 8085 is a 8-bit microprocessor, which implies that it is going to process a 8-bit data only. Means more than that, if you want to use, there is certain other rules to use that data, but it only processes 8-bit of data at a time. So that is why this processor is called as a 8-bit microprocessor. I hope you got this. So for the next, so we are having this W and Z registers also. These are temporary registers which are not being ever used by the user. So we are not going to use this. So W and Z are the registers, but they are never being used, and you are not able to use those registers. They are inside them. They are called as the some temporary registers over there. So these are W and Z. Then we have one more temporary register. This is called as the R temporary register over here near accumulator. So whenever we are going to add some data, one data is expected to be there in the accumulator. The second data, which can be taken from the memory like this, the data memory can be taken from this to here, or say it is in the register from some of the general purpose register. So that data can be taken from here and then it is put over here. So, so, yeah, hold it for a second. So, so again, one of the data should be in the accumulator. The other data can be processed from either memory or from this general purpose registers, and they have to store over here in the temporary register. So when we are having some arithmetic and logical operations, so one data is in the accumulator and the other data is in the temporary register. These two are being processed in this ALU, that is the arithmetic and logical unit, and after that the result which is obtained from this two data are again being stored in the accumulator itself. So remember this, the result of arithmetic and logical unit, whether it is an arithmetic operation or whether it is a logical operation, the data, the result is being stored in the accumulator in return, in back. It is stored over there itself. So this accumulator performs all the tasks and therefore it is a separate register. This is called as a spatial register, and that is why its name is there, accumulator, which means it accumulates all sorts of data. So this is a accumulator. Uh, Give me a second. So this is about the registers, general purpose registers, BC, DE, HL, stack pointer, program counter. Stack pointer keeps the address of the memory location where the stack data can be stored temporarily. Means if you want, there are only 6 general purpose registers. HL is used for memory location. Then we have left with only 4 registers, which is B, C, D, and E. So if all these 4 registers are temporarily full, so and if you require that we require some more registers to use, then what you are going to do? So in that case, you can store that data from these registers or from the accumulator in this memory location, which is given in the stack pointer. So we call them as a stack. So we can stack this data one by one, and during the another operations. We perform those operations, and then we can again take that data back to those registers. So that memory location address is being monitored or is being kept by this stack pointer. So this is called as SP. Program counter. Now we have to feed the program in some memory location. These memory locations are being recommended by different kits for different purposes. So what happens when we say we are loading the program from 6000. So in that case, 600 is the first memory location, and then we go on storing the instructions according to the outputs. So we will store that, and uh, lastly we will store the last instruction, that is supposed to be the hold, or if you want to put it in the infinite loop, then we'll have a loop. So after feeding those instruction or after feeding those program in there, we have to give the first address of the memory location. That means where the program is fed. That means when we have started with 6000, this is the first memory location where the program is fed. So that data is to be given to the microprocessor 600, and we have to uh, say push a button which is called as execute. So it starts to execute 600. So the first data is being stored in this program counter. Then it executes the first instruction. The next data is in the next memory location. So it keeps the track of that program. So in the next, again, it will take the other memory location and it will keep the track of 16 bits. So this program counter and the stack pointer are of 16-bit wide. Then, so these are all about the registers that we have, and these are being multiplexed. So if you are able to see, this green line is a 8-bit bit. This is called as a bus, 8-bit data bus, or say address bus, as whatever. So I have taught you today for three things. The architecture of 8085. The next will continue in the next class. So architecture of 8085. Okay, we are left with only 6 to 7 minutes. Sorry. Uh, wait for a second. Oh, is that fine? Is it visible? Hello, is it visible? Yes, you can
Yes.
chat. Thank you, thank you. So what I was telling is, again we will revise this. Um, it is an architecture of 8085, since it is very complicated and there are very many circuits inside it. So we are having a broad level diagram of 8085 architecture. So in that we are having 8-bit, 8-bit general purpose registers, GPRs, general purpose registers, namely P, C, D, E, H, and L. So these are 6 general purpose registers. Accumulator is also one of the general purpose registers, but it has to perform many jobs. Therefore, it is a separate register which is called as accumulator. So accumulator can also be used as a general purpose register. But uh, as I told you that for one of the data for arithmetic operations, one of the data should be in the accumulator, and the second data might be somewhere else. That might be in the memory, that might be in register B. So accordingly, there are instructions. So if I want to add the data of say register B to the register to accumulator, then what the instruction is, add B. So add B is the instruction. So add B will add the content or the data of register B to the content of the accumulator, and the result which is come out of that arithmetic operation is going to be stored in the accumulator itself, and the data of register B will be unchanged. So the only data is stored in register B will be same, but the data in the accumulator will be changed because the result is going to be stored in the accumulator. So by now, I hope this is more than enough for today. What I have again revised. So we'll again revise this. So we are having 6 general purpose registers. Then we have having SP, that is the stack pointer, which is going to keep the memory location track of the stack pointer. Then we have a program counter, which keeps the track for the program to continue, means memory location of the program. And then we have increment decrement address latch. Then this is again AD address buffer, data address buffer, which is again used to communicate with the other devices. So this same line is used for address line and same line is used for the data line. So the green one is for the 8-bit. So I hope for today, this is for enough. If you have any queries, you can unmute yourself and you can ask. We have only 3 to 4 minutes left. Shall I stop sharing? Okay, I will stop sharing. If you want, you can continue. So kindly let me know what if there are any queries, please. Hello, you can ask me on chat box also. Anyone? Is there any questions? You can even unmute yourself and ask. This means there is only 2 possibilities. Either you have understood completely or either you have not understood anything. Why we are studying and so. So, Shobit, you have any questions? Okay. Shall I ask somebody? How many of you are attentive? Let me ask Janvi. Janvi, how many general purpose registers are there? Janvi Jagdale. Hello? Janvi? Okay. Surbi, unmute yourself and Janvi, can you answer how many general purpose registers are there? Yes. Good. How many general purpose registers are there?
6.
Very good. B, C, D, E, H, and L. Right?
L.
So keep in mind that. Surbi, how many data lines are there? Surbi, you can unmute yourself.
I know.
Surbi?
16.
How
8
many
data
bit?
lines and 16 add lines.
16 address lines and 8-bit data lines, which means 8-bit data can be processed.
Data lines.
Very good. Then we have Nikhil also. Nikhil,
Yes.
is there Nikhil? Nikhil, you can unmute yourself. I have unmuted you from my side. Nikhil is there. Everybody has put their phones on somewhere. Sorry. So Nikhil is not present. Bhuneshwar Murthy, can you have joined? Bhuvi, where is Shobit? Yes.
Yes,
Shobit,
sir. Yes, sir. Yes, sir.
any questions?
No, sir.
Very good. So how many transistors are there in 8085? Shobit?
Sir, 2000, 6200.
Yes, 6200. Very good.
6200.
And which technology is used?
Uh, MMOS.
NMOS, yes.
NMOS.
N-type metal oxide semiconductor field effect transistor
Field effect transistor.
is used. Yes, very nice.
Yes, sir.
Then how much power supply is given? Uvi? Shao is there? No, Shao is not there. Bhuneshwar, can you answer this? Okay.
Regulated power supply.
5 volts plus 5 volt regulated power supply. Very good, Janvi. Very nice. Some more, Mayuri. Am I understood?
Yes, sir.
Thank you, beta. We can continue more. Huh? We will be doing some programs also. You can download some of the softwares of 8085 on your mobile phones, and we'll be giving some programs also on that. So we'll be starting that also along with this, right? And due to this admissions and all, I'm not able to communicate you properly, but we'll definitely be in touch, right? And don't miss any class and be on WhatsApp regularly. I will be uploading your notes on Google Classroom itself, right? So it's now okay. Nikhil, sound is not clear. Very good. Now, am I clear? Nikhil, am I clear now? You are not unmuted, no? Might be because of that. Okay. Shall we? So I will end this class today. I wish you all the best. Stay home, stay safe, and stay healthy. Bye. Take care. See you tomorrow in the morning at 11:25. Good day.